Section 14E, question number 6, page 357. The question here asks us to find dy by dx of the given function, x cubed minus 3x, from first principles. So we'll go about this the same way as using the limit definition of a derivative. So find the derivative. We're finding the limit when x plus h cubed minus 3 quantity x plus h minus x cubed minus 3x all over h as h approaches 0. So we'll expand this part out and expand this and then see what happens with a little bit of simplification along the way. So this x plus h gives us x cubed plus 3x squared x plus h cubed gives us, when we expand here, x cubed plus 3x squared h plus 3x h squared plus h cubed minus 3x minus 3h, and then minus x cubed plus 3x, the last two terms coming from expanding in this negative 1 into this bracket. And that is all over h. And then we'll go about finding zero pairs. So we got x cubed minus x cubed, that's a zero pair, which disappears then. Negative 3x plus 3x forms a zero pair. And that's all that we can simplify here. So now we'll just write the resulting line here, which is 3x squared h plus 3x h squared plus h cubed minus 3h all over h. We'll factor out an h from each of those terms, so that will help us simplify down with the denominator. So we've got 3x squared plus 3xh plus h squared minus 3 all over h, and h over h gives us 1. So the limit of 3x squared minus 3 plus 3xh plus h squared, I decided to bring this negative 3 over here after that first term. Oops, sorry, not over anything, as h approaches 0. I'm so used to drawing that line, but now I don't need it, of course, because that denominator was cancelled out in the previous line. And now we apply this 0, we substitute 0 in for h, and then dy by dx then gives us 3x squared minus 3, because when h is 0 substituted in for h here and here, those two terms become 0, so we're just left with 3x squared minus 3. So now if we go to question B then asks us, hence, find the points on the graph at which the tangent line has 0 gradient. So this is the gradient, or the gradient function, and the derivative, when that equals 0, that means that the gradient is 0 for the tangent line. And so now we'll just rearrange this to solve for x. So we'll add 3 to both sides to get 3 equals 3x squared. Divide both sides by 3, so we're left with 1 equals x squared. And then we take the square root of both sides, we end up getting x equals plus or minus 1. And now what we can do is when x equals 1, I'll substitute that into the equation, the original function, 1 cubed minus 3 times 1. That gives us 1 minus 3, gives us negative 2. So 1 point on the curve, when the tangent has a gradient of 0, is 1, negative 2. And then when x equals negative 1, again we substitute that negative 1 into the original function, and we get negative 1 plus 3, which gives us positive 2. Therefore the second point on the curve where the tangent has a gradient of 0 is negative 1 and 2.